Have you ever looked up at the night sky or pondered the depths of the ocean and felt a profound sense of wonder? A feeling that despite all our scientific advancements, there are still secrets, profound and baffling, hidden just beyond our grasp? Today, we're diving deep into the most enigmatic corners of our universe and our world, exploring 10 unsolved phenomena that continue to baffle the brightest minds in science. These aren't your typical mysteries. We've sought out the lesser known, the truly bizarre, and the ones that challenge our very understanding of reality. From the intelligence of a brainless goo to fires that refuse to die, prepare to have your perception of what's possible stretched to its limits. Stay tuned. Our first stop takes us to the mesopelagic zone, more commonly known as the ocean's twilight zone. This vast, dimly lit realm stretches from about 200 to 1,000 meters below the surface, where sunlight barely penetrates. It's a place of perpetual dusk, and what lurks within its shadowy depths remains one of Earth's greatest biological mysteries. Scientists believe this zone could harbor more fish biomass than all other ocean zones combined. Imagine an entire hidden world teeming with life we've barely begun to discover. These creatures, adapted to extreme pressure and near total darkness, play a crucial yet poorly understood role in regulating our planet's climate. They migrate vertically, bringing carbon from the surface to the deep, acting as a biological pump. But the sheer scale of this ecosystem and the intricate ways its inhabitants interact are still largely unknown. What other secrets does this immense dark ocean hold? From the deep blue to the fiery red, our next mystery takes us to Earth's planetary sibling, Venus. Once thought to be a lush, habitable world, Venus is now a scorching, toxic hellscape with surface temperatures hot enough to melt lead and an atmosphere thick with carbon dioxide and sulfuric acid. The question is, what happened? Scientists grapple with two main theories. Did a runaway greenhouse effect, perhaps triggered by a slightly closer proximity to the sun, cook Venus to death? Or was it a catastrophic volcanic resurfacing event, a period of intense volcanism that spewed immense amounts of greenhouse gases into the atmosphere, sealing its fate? The answer remains elusive, but understanding Venus's tragic transformation is crucial. It serves as a stark, chilling reminder of how fragile planetary climates can be, and what could potentially happen to Earth if we don't understand and respect the delicate balance of our own atmosphere. Prepare to have your definition of intelligence challenged by our next enigma, the humble slime mold. This brainless, single-celled organism, often found in damp, dark places, can exhibit behaviors that defy its simple biology. It can solve mazes, find the most efficient routes between food sources, and even anticipate periodic events, essentially remembering patterns. How does a creature without a brain, without a nervous system, achieve such complex problem-solving? Scientists are still trying to unravel this mystery. It seems to operate on a form of distributed, collective intelligence, where individual cells communicate and cooperate to achieve a common goal. Studying slime molds could revolutionize our understanding of intelligence itself, offering new paradigms for artificial intelligence and network design. It forces us to ask, is a brain truly necessary for smart behavior, or is there a more fundamental, universal principle at play? The recent pandemic brought widespread attention to long-haul symptoms, where individuals experience persistent health issues long after the initial infection has cleared. But what if this isn't unique to COVID-19? What if many viral infections can leave a lasting, debilitating impact that has largely gone under-recognized? Scientists are now exploring the possibility that a wide range of viral illnesses, from Epstein-Barr to Lyme disease, can trigger similar post-viral syndromes. The mystery lies in why some individuals develop these chronic conditions while others recover fully. Is it an overactive immune response, persistent viral reservoirs, or damage to specific organ systems? Unraveling the mechanisms behind these long-haul symptoms could revolutionize our approach to chronic illness, offering hope and understanding to millions who have suffered in silence for years, often dismissed by the medical community. It highlights a critical gap in our understanding of how infections truly impact the human body in the long term. What will life on Earth look like a million years from now? While predicting the future is impossible, the study of evolution allows scientists to speculate on how animals might adapt and change in response to ongoing environmental pressures, many of which are driven by human activity. This isn't just a thought experiment, it's a way to understand the profound and lasting impact we are having on the planet. Will some species shrink to survive in resource-scarce environments? Will others develop new sensory organs to navigate polluted landscapes? Could entirely new forms of life emerge from the ashes of the Anthropocene? The mystery lies in the unpredictable dance between genetic mutation, natural selection, and the unprecedented speed of human-induced environmental change. Understanding these potential evolutionary pathways helps us grasp the long-term consequences of our actions and underscores the incredible resilience and fragility of life on Earth. It's a glimpse into a future shaped by forces we are only beginning to comprehend. From the macroscopic to the microscopic, our next mystery is a marvel of nature that happens right before our eyes, yet remains profoundly unexplained: the complete transformation within a chrysalis. We know a caterpillar enters and a butterfly emerges, but what truly happens inside that seemingly inert casing is a biological enigma. Inside the chrysalis, the caterpillar essentially dissolves into a biological soup, its body breaking down into imaginal discs, tiny clusters of cells that contain the genetic instructions for the adult butterfly. But how do these cells know exactly how to reassemble themselves into an entirely different creature? How is this complex blueprint stored and executed with such precision? The mystery lies in the incredible cellular programming and the intricate dance of genetic expression that orchestrates this complete biological reorganization. Understanding this process could unlock secrets to regeneration, developmental biology, and even offer insights into how life itself builds such complex forms from seemingly simple beginnings. It's a testament to the profound intelligence embedded within nature's most intricate designs. Why is the universe the way it is? Why do the fundamental constants of physics, like the speed of light, the strength of gravity, or the charge of an electron, have the precise values they do? These aren't arbitrary numbers. Even a tiny deviation in any of them would render our universe and life as we know it impossible. This profound mystery, often referred to as the fine-tuning problem, has puzzled physicists and philosophers alike. Is it merely a cosmic coincidence, a stroke of immense luck that we happen to exist in a universe perfectly calibrated for life? Or does it hint at a deeper underlying principle, perhaps a multiverse where every possible combination of constants exists, and we simply find ourselves in the one that supports our existence? The implications are staggering, touching upon the very nature of reality and our place within it. It challenges us to consider whether our universe is a unique masterpiece or just one of an infinite number of possibilities. As we delve deeper into the fabric of reality, we encounter a fundamental barrier: the Planck scale. This is the realm of the infinitesimally small, where our current understanding of physics breaks down. At these scales, concepts like length and time become fuzzy, and the elegant laws of classical mechanics give way to the bizarre, probabilistic world of quantum mechanics. The mystery isn't just our inability to measure below the Planck length. It's the profound disconnect between the two pillars of modern physics: general relativity, which describes the universe on large scales, and quantum mechanics, which governs the very small. They are both incredibly successful in their respective domains, yet they are fundamentally incompatible. How can the universe operate under two seemingly contradictory sets of rules? Bridging this gap, finding a unified theory of everything, remains the holy grail of physics. It suggests that our current understanding of reality is incomplete, and there's a deeper, more unified truth waiting to be discovered at the very foundations of existence. Imagine tuning into your radio, expecting music or news, and instead hearing a disembodied voice reciting a series of seemingly random numbers. This is the eerie reality of numbers stations, and one of the most persistent mysteries among them is HM01, believed to be a Cuban shortwave numbers station.
For decades, these stations have broadcast coded messages, often in various languages, with no clear explanation for their purpose. While many speculate they are used for espionage, transmitting instructions to undercover agents, the exact nature and recipients of HM01's messages remain unconfirmed. Who is sending these cryptic broadcasts, and to whom? The mystery of number stations like HM01 highlights a hidden world of clandestine communication, a relic of the Cold War that continues to operate in the digital age, a silent, persistent whisper across the airwaves that science, or at least public knowledge, cannot fully explain. Mystery takes us to the frozen north, where a chilling phenomenon known as zombie fires is baffling scientists and posing a growing threat. These aren't your typical wildfires. They are fires that smolder underground, often in peatlands, throughout the harsh winter, only to re-emerge and reignite on the surface when spring arrives. The mystery lies in how these fires survive months beneath layers of snow and ice, seemingly defying the elements. While the general consensus points to the insulating properties of peat and the slow, oxygen-deprived combustion, the exact mechanisms and the conditions that allow them to persist remain a subject of intense research. Are they a direct consequence of climate change, with warming permafrost creating new fuel sources? Or are there other unknown factors at play? Zombie fires highlight the complex and often unpredictable feedback loops within our planet's ecosystems, reminding us that even in the most extreme environments, nature holds secrets that continue to challenge our understanding and demand our urgent attention. From the deepest oceans to the farthest reaches of space, and even within the simplest forms of life, mysteries abound, pushing the boundaries of our knowledge and inspiring new generations of scientists. Which of these mysteries intrigued you the most? Do you have a favorite unsolved scientific puzzle? Let us know in the comments below. If you enjoyed this journey into the unknown, please give this video a like, subscribe to our channel for more mind-expanding content, and share it with anyone who loves a good mystery. Thank you for watching.